Hello guys, so back with another lead code question. This question has been asked in the last lead code contest. The question number is 3015. Count the number of houses at a certain distance 1. Yeah, so I'm solving the first one. I'll be posting the solution for the second one as well. But for now, let's try to do the first one. So what's the problem here? The problem says that you are given three positive integers n, x, and y. In a city, there exist houses numbered from 1 to n, connected by n streets. There is a street connecting the house number I with the house number I plus 1 for all the houses. Okay, an additional street connects the house number x with house number y. That means there is an extra street which is from x to y. For each case such that case in between 1 to n, you need to find the number of pairs of houses, house 1 and house 2, such that the minimum number of streets that need to be traveled to each house 2 from house 1 is k. Okay, so return I turn the I one index array result of length n, where the result k represents the total number of pairs of houses such that minimum number of required streets required to reach the house from the other house is k. So the question says that we are having houses in a line, okay, and there is a street which is connecting all the adjacent houses, but there is an extra street which is connecting the x house to the y house, x number house to the y number house. For in this case, the x is equals to 1 and y is equal to 3, so 1 and 3 are connected with an extra street. And if we move downwards, we'll see in this case the x and y are 2 and 4. So you can see now, first off, we need to find out the minimum number of streets we need to travel to reach any two houses. So first what we'll do, we'll be creating two for loops. We need to find out for every pair of houses, like we have to create all the pairs, and we have to find out the minimum number of streets required to travel from one house to another house. Okay, so for that we need to first off create a for loop, and let's create let's create a array which is going to be our answer, and that will contain zeros to n. Okay, this is going to be our answer, that's why. Yeah, and first off, we in this case we are having one index array, so it would be better if we reduce one from x and y as well, because we are going to be operating on a zeroth index array. Okay, so that's the reason I did this. So yeah, now we have n houses which are connected with adjacent houses are connected, and we have an extra street which is from x to y. Okay, so first off we need to create all we need two for loops for and for j. Yeah, so now we'll be creating all the pairs 1 2 1 3 1 4 1 5 2 3 2 4 2 5 3 4 3 5. So we'll be creating all the pairs, and then we will be calculating the minimum distance need to travel to reach from one pair to from one house to other in the pair. Okay, and then we'll be increasing the count in this answer array. Okay, and we'll be increasing it by 2. So what is going to be the minimum distance? So yeah, to for example, from first house to fifth house, what are the options here? Either we can travel in straight line, or we can travel to 2 and then we can jump to 4 and then we can go to 5. So we have two ways to travel. Okay, either first reach 2 and then reach 4 and then reach your destination, or go directly. So for the first case, let's call it A, what is going to be our distance? So the distance is going to be abs of I minus x, okay, and plus abs of y minus x, okay, y minus j, okay. So, or I should write j minus y. So what will this give us? This will give us the difference between the first index and x, and the difference between second index and y, and we also need to add 1 for this jump, okay. That is also a step, right? So I'm using abs because in case where I is greater than x, there also we will be getting the difference, because we only need the difference. That's why I'm using abs for in case, like let's assume, I'll show you an example. Let's assume these are our houses. We need more houses, okay. Now if we have if we have here, we have the x and y like this, okay. So we can also to reach from this house to this house, we have two options. Either we can travel this way, or we can travel like 1 and 2 in 2 steps. And for this house as well, we can either travel 1 2 3 steps, or we can go from 1 2 and 3. So we can also use this correction for to travel from this house to this house as well. So using the abs makes it easier to calculate the difference, okay. Now let's jump to the second case. So what is the second case? Second case is that we can travel straight in a straight line, going through all the houses in our way. So that is also awesome. Like for example, if you are to travel from this house to this house, it's better to just travel directly rather than going through x and y. So yeah, so in the second case, what is going to be the difference? That's the difference is going to be j minus I, yeah. And one thing we have to take care that it's not mentioned that x and y, that they are in, that y is greater than x. So we have to make sure that our y is always greater than x. So if x is greater than y, in that case, what we'll do is x comma y will be equals to y comma x. We'll just swap the values. We are swapping the values in case x is smaller, x is greater than y, okay. So yeah, here or the difference is going to be b j minus I, that's it. Yeah, and the minimum difference of these two is the value we need to care about. So whatever comes minimum, like let's say min mi and d, minimum difference b equals to minimum of a and b. So yeah, these were the two roads we could have taken, and we have to take the one which is the minimum distance, okay. So yeah, we have taken the minimum road, and then we will update answer minimum d with a plus equals to 2. We are doing 2 because for every minimum distance there are going to be two pairs, because here you can see that they are repeating the pairs. They are using 1 2, and they are also using 2 and 1. So we have to keep that in mind, and we'll for every pair, like for every 1 2 or 2 1, we'll be adding 2 to our answer array. Okay, now our array is constructed, I think, and we are ready to return it. Return array, sorry, answer. Let's see, let's try to submit it. Okay, so yeah, we are getting wrong answer, and that is because we need to return a one indexed array, but this one is a zeroth index array. Okay, so yeah, what we can do here is we'll just do this plus 1. Yeah, that could be done. And then when we'll be storing the minimum differences, there won't be an issue in the future. And then what we'll return here is we'll be just slicing it, just slicing the first element out. Let's try to run it. As you can see, our first three test cases are passing successfully. Now let's try to submit it. Yeah, we have a submission, successful submission. So I hope you understood. Stay tuned for more solutions.